The garbage collection scheduler manages heap reclamation across allocated memory regions. The system operates in discrete collection cycles, each initiated by heap pressure thresholds or explicit invocation. Collection phases include mark, sweep, and compaction stages. The scheduler tracks generational boundaries to optimize reclamation frequency. Younger generations are collected more frequently than older generations due to empirical survival rate distributions. Pause time prediction uses historical collection statistics to estimate stop-the-world duration. The scheduler maintains a rolling window of the previous 16 collection operations, recording mark time, sweep throughput, and compaction cost. Pauses exceeding configured maximum thresholds trigger incremental collection modes. Incremental collection distributes work across multiple shorter pauses rather than single long suspension periods. The mark phase traverses reachable objects from root references. Root references include stack variables, global pointers, and thread local storage. The traversal uses breadth-first ordering to maintain cache locality during marking. Objects are decorated with color values. White indicates unmarked state, gray indicates marked but unvisited children, black indicates complete traversal. Concurrent marking uses atomic operations to coordinate worker threads. The sweep phase reclaims white objects determined unreachable during marking. The allocator maintains precise class-free lists populated during sweep. Fragmentation is mitigated through address-ordered sweeping, which coalesces adjacent free blocks into larger allocatable regions. Sweep speed depends on heap size and object count. The default sweep throughput is tuned for typical workload patterns. Compaction reduces external fragmentation by relocating live objects. Compaction operates in two phases. Placement phase calculates new addresses for all objects. Relocation phase updates references in the heap and roots. Compaction is not always necessary if free lists satisfy allocation requests. The scheduler enables compaction only after fragmentation exceeds configured thresholds. Generational hypothesis observes that most objects are collected shortly after allocation. Generation divisions partition the heap into young and old spaces. Young generation collections occur frequently with smaller scan scope. Old generation collections are triggered only when young generation promotion rate exceeds thresholds. Cross-generational pointers are tracked using write barriers. Write barriers intercept pointer assignments to detect old to young references. The write barrier implementation uses card marking. The heap is divided into fixed-size card regions, and writing to any object in a region sets a dirty bit. During young collection, only dirty cards are scanned for old to young pointers. Card size affects barrier overhead and collection scope. Concurrent marking executes during application execution to reduce stop-the-world pause. The mutator and collector thread coordinate using tricolor invariant. Black objects are never reachable from white objects. Concurrent marking requires atomic reads and compare exchange operations. Incremental update barriers track references written during concurrent phases. Collection trigger policies determine when collection cycles initiate. Threshold-based triggers fire when heap usage ratio exceeds configured percentage. Time-based triggers initiate collection at fixed intervals regardless of heap state. Adaptive triggers adjust thresholds based on recent allocation rates and pause times. Multiple trigger mechanisms can be active simultaneously. Promotion from young to old generation occurs when objects survive a configured threshold of young collections. Promotion is synchronized during collection to avoid race conditions. Objects are promoted in bulk batches during the young collection that triggered promotion. Old generation promotion cost factors into young collection pause time estimation. The allocator maintains multiple free list pools segregated by object size. Size classes follow power of two boundaries to minimize external fragmentation. Fast allocation succeeds when a free object matching the requested size exists. Slow allocation triggers a collection cycle if all size classes are exhausted. Evacuation during collection moves objects from high fragmentation regions to contiguous target regions. Evacuation happens concurrently with application threads where possible. Reference updates occur in two stages: primary object reference updates during collection, secondary reference updates during a brief stop-the-world phase. Evacuation reduces long-term fragmentation without full heap compaction. Finalization handling executes user-defined cleanup code when objects become unreachable. Finalization is delayed. Unreachable objects with finalizers are moved to a separate queue. Finalizers execute in a background thread, and objects are collected in subsequent cycles. Finalizer exceptions are logged but do not interrupt collection. Finalizer execution order is undefined. Statistics collection tracks heap size, collection frequency, pause durations, and promotion rates. Statistics are maintained in thread local buffers to avoid contention. Periodic statistics aggregation occurs between collection cycles. Statistics guide adaptive threshold adjustment and inform performance monitoring systems. Configuration parameters control collection behavior, target pause time, generation promotion threshold, card size, free list pool count, and concurrent worker thread count. Parameters are specified during runtime initialization and remain constant during execution. Invalid parameter combinations are detected during initialization and logged with remediation suggestions. The scheduler logs collection phase transitions, pause durations, and reclaimed byte counts to persistent event stores. Log entries include timestamp, generation, phase name, and performance metrics. Logs are aggregated and visualized for performance analysis. Detailed logging modes provide thread-level tracing for debugging specific collection issues.